Welcome to the first session of atomic structure. Let's now first understand that what exactly an atom is. We know that everything around us is made up of matter. But we have never thought about what matter is made up of. If we go on dividing any substance till the point when it cannot be divided further, that part of the substance is called atom. Atom is a Greek word where A means not and tomos means cut, means atom is uncuttable. Atom is something which cannot be divided further. John Dalton gave a list of postulates under the name atomic theory. Let's first take a look at these postulates. The first postulate is that, according to the Dalton's theory, an atom is the smallest indivisible part of matter which takes part in chemical reaction. Atom is neither created nor destroyed. This is the second property. The third postulate is that atoms of the same element have similar size, mass, and characteristics. However, atoms of different elements have different size, mass, and characteristics. Let's now discuss about the structure of atom. Look at this illustration, which is showing you the structure of an atom. An atom is mainly made up of three subatomic particles called electron, proton, and neutron. These particles are called the fundamental particles of the matter. The basic structure of the atom contains a positive center which is called nucleus. Protons and neutrons are located in this nucleus, whereas electrons are revolving around this nucleus in the orbitals. Electrons have negative charge on it, protons are positively charged, whereas neutrons carries no charge. Let's now study about the cathode rays. For that, let's understand the experiment done by J.J. Thomson. The arrangement consists of a glass tube filled with the very low pressure of a gas. The glass tube contains two metal plates called as anode and cathode. Anode is that metal plate which is attached to the positive side of the battery, and cathode is that metal plate which is attached to the negative side of the battery. And these are connected to the very high voltage greater than 10,000 volt. Usually, gases are bad conductor of electricity, but due to the reduced pressure and this high voltage, they conduct electricity. When the power was switched on, it was noticed that the cathode emits some invisible rays, which travel towards the anode. The anode consists of a hole through which these rays travel and strike the curved surface and creating a bright glow at the end of the tube. Actually, it is a stream of electrons evolving from the cathode, which being negatively charged get attracted to the anode. As we know that positive charge attracts negative charge and vice versa. J.J. Thomson also calculated the charge to mass ratio with the help of this experiment. This is called the charge to mass ratio, which the value was given to be for the electron coulombs per unit of mass. Coulombs is the unit of measuring the electric current or the charge. Charge on the electron was calculated by the Milkian oil drop experiment. In this experiment, it was found that the charge on each drop was calculated the multiple of 1.6 into 10 raised to power minus 19 coulomb. Which meant that the electrons carried this unit charge. If we talk about the electron, then this charge will become negative. And if we talk about the protons, this charge will become positive. Based on this experiment, we can say that these cathode rays travel in the straight line, because when a metallic object is placed in the path between of these cathode rays, these rays cast shadow on the wall opposite to the cathode. Being a beam of electrons, they travel from cathode. They are negatively charged because they got deflected towards the positive plate when kept in an electric field. Electric field is nothing but a field created by two electrodes having positive and the negative charge. The glass surface on which the cathode rays strike show colored shine. They cause green fluorescence on the glass surface. The particles of cathode rays possesses energy. That energy is kinetic energy, as they tend to set a pedal wheel into motion when it is placed in the path of these rays. Cathode ray particles strike the blades of the pedal wheel and set them into motion. Cathode rays can ionize gases through which they pass. The nature of the cathode rays are independent of the nature of the cathode used and the gas in the discharge tube. The discovery of cathode ray gave rise to one more set of rays observed by Goldstone and J.J. Thomson. These were the anode rays emitting from the surface of the anode when struck by the beam of electrons. From the same set of cathode ray tube experiment, anode rays also came into picture. They had the following features. The first feature was the same, that they also traveled in straight line, which was proved as they casted the shadow of a metallic plate or any substance on the opposite side of the wall. They also rotate the pedal wheel when placed in their path. The third feature which they showed was that they were deflected by the magnetic field. In the presence of electric field, they travel towards the negatively charged plate, indicating that they are positively charged. The next property is that these rays affect the photographic plate. Next property is that their nature of anode rays depend upon the type of gas used in the discharge tube. Even the charge to mass ratio of anode rays particle is different for different gases used in the discharge tube. The value of charge upon mass ratio is maximum for the hydrogen gas. Here we have used the hydrogen gas in the discharge tube. So discharge tube consists of an atom of hydrogen gas. During this experiment, the atoms of the gas loses negatively charged electrons, giving rise to the positively charged particle, which are produced from the hydrogen gas. And these particles were called protons. Hydrogen is represented in this way. When it loses an electron, it gives rise to proton. Protons, which were thousands times bigger than the electrons in terms of mass. The charge upon mass ratio for the proton was This was the discovery of protons and anode rays. In this session, we are going to discuss about the different models proposed by different scientists regarding the structure of atom. Next, we are going to look at Sir Thomson's model of an atom. After the electron's discovery, Thomson tried to draw the structure of atom. Let's see. Electrons are evenly distributed. As you can see in this diagram, that he thought that the atom to be consisting of electrons negatively charged surrounded by a positive sphere. This structure looks like plum pudding model, that the electrons, where the electrons are considered as plums and the positive sphere as pudding. That's why this model is also called plum pudding model. But this model failed as it could not explain the stability of an atom. An atom can only be stable if it has equal positive and the negative charges. But here he did not explain about the distribution and arrangement of the electrons with respect to the positive sphere. He also considered the mass of the atom to be evenly distributed, which is not the case. Later, Ernst Rutherford gave a new picture of the structure of atom by his alpha particle scattering experiment and proposed the structure of atom. He set up an apparatus like this in which he bombarded the alpha particles on a very thin sheet of gold foil. What are alpha particles? Alpha particles are nothing but the helium particles, and they had 2+ charge on them. So he bombarded these alpha particles on thin sheet of gold foil. It was noticed that most of the particles passed straight through the gold foil without any deflection. Instead, some got deflected as they passed through and some bounced back at 180 degrees. From these observations, he concluded that the positive mass of the atom must be concentrated in a very small area, as most of the particles didn't show any deflection, which means that most part of the atom was empty. That's why the particles didn't reflect it back. Most of the atom space was empty, as we just discussed. The electrons revolve around the nucleus in the orbits. This model of atom also failed as he could not give the exact location of the electrons. Moreover, when he explained that the electrons were charged particles and they were revolving around the nucleus in a circular motion, it could mean that they will lose energy and these electrons would fall into the nucleus, and thus this atom will become unstable. But that is not the case. Atom is very stable. Also, Rutherford could not explain the colored spectra which was obtained during this experiment. Now, the next is that Sir Niels Bohr also composed a theory which focused on the outer part of the atom, which is outside this nucleus. He created the first model that considered the phenomena of absorption and emission of the radiations. The theory he proposed is called as Bohr's theory. Bohr's theory says that negatively charged electrons revolve around the nucleus in well-defined orbits or shells, and each shell having a definite amount of energy associated with it and associated with its electrons. Therefore, these shells are also called energy levels. As the radius of the orbit increases, the energy of these orbits also increases. These shells are also known as K L, M, N, and so on shells, starting from the closest to the nucleus. Look at this diagram. An electron can jump from lower energy level to the higher energy level by absorbing some amount of energy. Now this energy is given by an equation which is here. This constant is called Planck's constant, and this is the frequency of the radiations emitted. You will study about this equation in the higher classes in details. Similarly, an electron present at the higher energy level can come down to lower energy level by losing energy in the form of radiations. Because if the electron is coming to the lower energy level, which has low energy as compared to the energy of the higher energy level in which it is present, it has to lose that much of energy and make its energy equal to the energy of the level in which it is coming. The amount of energy absorbed or emitted is given by the differences of energies associated with the two levels, which means the change or the emission of energy is represented by this. This means change. It is called as delta. This change in energy will be equal to E2 minus E1, where E2 is the energy of that energy level where the electron is going and E1 is the energy from where the electron is coming. This theory helped us to look through the atomic structure with greater clarity and accounted for the stability of an atom. Meanwhile, a problem arises that the number of electrons and protons did not match with the calculation of masses, which initiated the discovery of third particle that is called neutron. Sir Chadwick proceeded with the bombardment of alpha particle with beryllium sheet, which emitted a stream of radiations. These radiations remained unaffected in the presence of electric or magnetic field, and these are called neutrons. These particles did not carry any charge. With this, we have completed the structure of atom. With this, we have come to the end of this session where we have discussed different models of the structure of the atom. In the next session, we will discuss about atomic structure, atomic mass, and mass number. Thank you. Welcome students. In this session, we are going to discuss about atomic number, mass number, isotopes and isobars. Now let's look at what is atomic number and mass number first. Atomic number. The atomic number is defined as the total number of protons present in the nucleus of an atom, which is also equal to the number of electrons present in the atom outside the nucleus. It is denoted by Z. For example, let's take, so any element is represented in this form, where Z is the atomic number and A is the mass number. In the similar way, we have represented carbon, where the The atomic number of carbon is 6, which means that they have 6 number of protons, which is also equal to 6 number of electrons in this atom. Now let's look at what is the mass number. The mass number of an atom is defined as the sum of the total number of protons and neutrons present in the nucleus of an atom. For example, the mass number of the carbon is 12 and it has 6 number of protons. We can calculate number of neutrons by subtracting 6 from the mass number, which means 6 number of protons and 6 number of neutrons will give you the mass number. Now let's discuss few more terms. What is valence shell, valence electron and valency? Now valence shell is the outermost shell of an atom. Say that if this is an atom and it has only 2 shells. In this case, L will be the valence shell. The number of electrons which will be present in the valence shell are called valence electrons. Then what is valency? Valency is the number of electrons gained, lost and shared to complete 8 electrons in the outermost shell is called valency. Now why I have said to complete the 8 electrons? The outermost shell of any atom can have maximum of 8 electrons according to the octet rule. You will study about this rule in the further classes. Let us understand few more terms. Isotopes and isobars. Isotopes are the atoms of the same element having the same atomic number but different mass number. For example, there are 3 isotopes of hydrogen. As you can see, they all have the same atomic number, that is 1, whereas they have different mass number, that is 1, 2 and 3. This is hydrogen, this is deuterium and this is tritium. Now this hydrogen atom has 1 proton and 0 neutron. This hydrogen atom or isotope has 1 proton and 1 neutron. Whereas this atom has 1 proton and 3 minus 1, 2 neutrons. Now let's discuss more that how we can calculate the atomic mass of these isotopes. Let's take an example. Let's take an example of the chlorine isotopes. So there are 2 isotopes of chlorine, one with the mass number 35 and another with the mass number 37, and they are present in 3:1 ratio in the nature. So the atomic mass of this isotope will be 37 into its ratio plus 35, the mass number of another isotope, into its ratio divided by the sum of the ratio. If you'll calculate, this will come to be 35.5 U. Now let's discuss what are isobars. Isobars are the atoms of different elements with a different atomic number which have the same mass number. They are known as isobars. For example, this is the isotope of carbon. You can see that these have different atomic number, but they have same mass number. Let's try to solve few questions. First question is, calculate the number of electrons, protons and neutrons in the following species. First is phosphorus atom. Now, the mass number of the phosphorus atom is 31 and its atomic number is 15. Second part is, we need to calculate electrons, protons and neutrons for phosphide ion. It is represented this way. Now let's solve this. We know that the atomic number of the phosphorus atom is 15, which means the number of protons is equal to 15. The number of protons equals to the number of electrons. We know that. Therefore, the number of electrons is also equals to 15. We know that the mass number is the sum of the number of protons and number of neutrons. Therefore, number of neutrons will be mass number minus number of protons, which is equal to 31 minus 15, 16. Hence, we have calculated the number of electrons, protons and neutrons for phosphorus atom. The next is for phosphide atom. Now, phosphide atom is achieved when the phosphorus atom has gained 3 electrons. Now let's look at how many protons, electrons, neutrons it has now. Proton has atomic number again 15, which means the number of protons are still the same, which is equals to 15. But now, as it has gained 3 more electrons, then the number of electrons is equal to 15 plus the number of electrons gained, which is equal to 18. Now we know again that the mass number is equals to the number of protons and number of neutrons. So again, the number of neutrons will be equal to mass number minus the number of protons, which is again 16. Let's discuss another example. Let's calculate the number of protons, electrons and neutrons for magnesium ion. And magnesium ion is represented as magnesium 2+. The atomic number for the magnesium ion is equals to 12 and mass number is equals to 24. Now, the number of protons is equals to the atomic number, so the number of protons is equals to 12. As this magnesium ion has lost 2 electrons, it means the number of electrons minus 2, which is equals to 10. The number of neutrons will be mass number minus number of protons, which is equals to 12. Now let's look at another example. The number of protons in the nucleus of an atom of mass number 97 is 41. What will be the number of neutrons in its isotope of mass number 99? Now let's try to solve this. Isotopes have same atomic number. Therefore, the number of protons in both the atoms is same. Mass number is given as the number of protons plus number of neutrons. Mass number is given as the number of protons plus number of neutrons. Thus, the number of neutrons is equal to mass number minus protons, which is equals to 99 minus 41, which is equals 58. So we have got the number of neutrons. Let's take another example. Calculate the atomic number of an element whose mass number is 31 and the number of neutrons is 13. What will be the symbol of this element? Now, from the definition of mass number again, mass number is equals to number of protons and number of neutrons. So the mass number can also be written as atomic number plus number of neutrons. So the atomic number is equals to mass number minus neutrons, which is equals to 31 minus 16 equals 15. So this way we have got atomic number of this element. Now the atomic number of phosphorus is 15. So which means this element is phosphorus. Now let's start another question. If bromine atom is available in the two forms, say isotope 1, which is existent in the percentage 49.7%, and another isotope which is present in the nature at this percentage, calculate the average atomic mass of bromine atom. Now the mass number from this isotope atom is 79 and the mass number of this bromine isotope atom is 81. So the atomic mass for the bromine atom, which has these two isotopes, will be 49.7 into 79 plus 50.3 into 81 divided by 49.7 plus 50.3. After the calculation, you will get 80. Hence, we have calculated the atomic mass of bromine, which is 80. With this, we have come to the end of this session. In the next session, we're going to study about where the electrons are actually located in the atoms.